Welcome everyone to Graph Gurus 46. In this episode, we'll be covering the latest product updates from TigerGraph, both related to the recently released version 3.1 as well as our cloud offering, TigerGraph Cloud. First, we'll start with some introductions. My name is Rais Pasha. I'm the product lead for the core database product. I've been at TigerGraph for 1.5 years now. My areas of responsibility include the TigerGraph database engine platform. And prior to TigerGraph, I've held PM roles at Workday, Hitachi, and HP. I have a master's in computer science, and my area of expertise is database management and big data technologies. And joining me on the webinar today is my colleague, Emma Lu. Emma leads the product management for the TigerGraph Cloud as well as the application areas of the product. She has worked previously at Oracle MarkLogic. She has a bachelor's of engineering from Harvey Mudd College and an MS in engineering systems. Her focus at TigerGraph is cloud containers, enterprise infrastructure monitoring, management, as well as data connectors. So first, before we begin the webinar, some housekeeping items. First, although your phone is muted, we don't want to hear from you. We want this to be interactive. We want to answer all your questions. So please do submit your questions at any time using the Q&A tab in the menu as shown in the figure. And then next, we also are recording this webinar and it will be uploaded to our website shortly after the session is done. And the URL will be emailed to you. And lastly, if you experience any technical issues, please be sure to contact one of the panelists through chat so that we can pause and address the issue right away. So for today's webinar, the outline is as follows. We'll kick off the webinar with an update from the TigerGraph Cloud side. Emma will present the tech feature updates as well as the business side pricing updates that we have added recently to bring everyone up to speed. Next, I'll present the version 3.1 product updates, including introduction to all of the key features that we're delivering as part of version 3.1. After the 3.1 updates are done, we really want to emphasize and underscore how important cloud is to our product, and everything we have delivered in 3.1 are geared towards enabling TigerGraph to be a top-notch database vendor on the cloud space. So Emma will have some additional detail on things that are very pertinent to what cloud and how these features apply. And then finally, we'll take questions in the end. All right. Now at this point, I want to toss it to Emma to begin the first part of the webinar. Emma, over to you.
Okay, thank you. So you can stop sharing and I will start sharing my slides. All right, yeah, very happy to present what we have included in our last December update for TigerGraph Cloud. So just as an overview, TigerGraph Cloud is releasing pretty much every month with some of the major updates. I think in 2021, we are going to even increase this release cadence so that more the users can get a lot of the newer features in very fast and take advantage of all the new and shining cool features that TigerGraph Cloud provides. And we're also going to uptake more of the application feature and the database side of changes in a faster approach as well. So in last December, we included the following changes. The biggest changes is from the business side, we actually provided new TigerGraph Cloud pricing. And if you have a comparison, some of this pricing reduction on the instance hourly pricing is up to even 70%. So it's we really want to help everyone to use graph analytics, and by reducing the price, we think that it's will help us to help you to really bring graph analytics to your organization. So that's one of the biggest business updates that's on TigerGraph Cloud platform. The second one is we actually included one more type of sizing option, which is a TGC4M16 on AWS. This is our most affordable option right now. So if you have really small experiments and very small data set, this is a good instance for you to use as well. And then in terms of starter kits, we actually included one new machine learning starter kit, which is exclusively on version 3.06, is Graph Convolutional Network starter kit. So take a look at that starter kit. You can see how TigerGraph can be used to do graph convolutional network and the in-database machine learning. And we also included 4 more starter kits, which were upgraded from 2.6.4 to version 3.06. And one more exciting news is for version 3.06, there are more replication options now. You can choose replication, up to 3 replicas for higher query throughput and availability. So all these are very exciting news and new features, and we hope that this will help you to use TigerGraph faster and in a more efficient way. All right, just a little bit on the new pricing. So these are the new pricing on the AWS instances. As you can see, we on the website, we provided some of the machine specs for each of the solution instance type on AWS. And then we also have kind of a sizing and rough estimation that you can think about when you think about your data size versus what kind of machine you're going to use. And also the disk recommendation. We do recommend you to use this guideline and use a appropriate size of disk so that you don't run into some of the issues that we've seen. And of course, these are the new pricing, and also the price of the replica is the same of the primary data copy. So this is also a change that we changed from the previous pricing to the current December pricing. So going forward, we'll be using this pricing until further adjustments. Again, this is a similar table for the pricing on Azure. And in February and March, we're going to add more instances to Azure so that you will see more of the Azure instances here. So just go back. Again, this is the URL for the pricing, and there's a lot of questions and answers there that explains all the details. But just a high-level overview on how you calculate your TigerGraph Cloud pricing. Basically, there are 4 components. One is the instance price, which is by instance hourly price and multiplied by the time that you're using it. The second is really the storage price, which is the disk size plus the multiplied by the partition factor, multiplied by replication factor, and then by the storage price and by time. And the third one is actually the backup price, which is this size by the partition factor. Notice that there is no replication factor here because we only need one backup. So the backup price by the time. And then there's a last piece is a data transfer cost. And currently we are actually charging less than the cloud platform charges for the data transfer cost. And this item, it's currently pretty minimum compared to all the other price. All right, just a quick example. I chose one example that if you provision a distributed TigerGraph system with 2 partitions and 2 replicas, and you decide to choose the TGC16 M64 and also provision a 180 gig disk, and your data transfer is 245 gig for this month. And what you end up paying is if you keep this instance running the entire month, you will be paying instance price plus the backup price, and then there's a storage price, and then there's the total price in the end. And then here, if the instance is stopped but not terminated, again, like when you are stopped and not terminating the instance, the solution, the EC2 instance or the Azure instance behind is actually not used. So that's why when you're paying the price, you're only paying the backup and the storage cost when you are stopping your solution. Again, there is a data transfer cost, but it's pretty minimum compared to, and actually less than what the cloud platform charges. And it does show up in the next few months invoice. All right, so just one thing that I want to talk about is, on tgcloud.io, that you can have many different workloads because of the consumption model. You can, provision the instance, start, stop, and terminate as you like. And of course, you can have all different types of clusters, which is designed for the development, staging, testing, and production purposes. And you can also just have, multiple TigerGraph clusters, and you can also experiment with, multiple TigerGraph versions. So this is a very good place to really have multiple TigerGraph clusters under one account. And for payment methods on tgcloud.io, if you just log into your tgcloud.io portal, the first method is pay as you go using entering a valid credit card. And of course, I think everybody who has used the platform also knows that there is a free tier where you don't need to enter the credit card, but still leverage the free tier to play with the TigerGraph solutions. But when you're using a paid tier, you can use pay as you go option using a credit card. The second approach is actually you can purchase TigerGraph Cloud credits in bulk. And then this can be discussed with our sales team, and you can buy the TigerGraph Cloud credits. And the third one is, again, when you speak with our sales team, there can be long-term contracts arranged on TigerGraph Cloud as well. Okay. So next, I want to talk about the new and improved starter kits on tgcloud.io. Just to recap, we have every month or two, we'll add new starter kits and also improve the existing starter kits. And in December, we added the new machine learning starter kit, Graph Convolutional Network. And then for the other four, we improved and upgraded the starter kits from the version 2.6.4 to version 3.06. So you can, again, using these four starter kits on the V3 versions. I'm just going to, narrow down to one demo, which is the Graph Convolutional Network. And there is a blog on the Medium that actually explains, all the details and the use case behind this. It is a pretty, if I want to expand on this, it will take a long time. We'll have a special, webinar later to explain the Graph Convolutional Network again on TigerGraph Cloud. But currently, I'm just going to demo you, how you get to the Graph Convolutional Network on tgcloud.io. Okay. Let me just stop share, and let me get back to share screen. Actually, I need to exit first. Okay. Let me bring up the Chrome tab again. Okay, here we are. Again, let's look at, this is the Medium blog that's actually talking about the details of the graph convolutional networks. So you can get into a lot of details on, the algorithm and as well as how it's done. And but because of the time limit, I'm just going to show you how you can get to the starter kit from TigerGraph Cloud. First, this is the TigerGraph Cloud tgcloud.io dashboard, and you can create a solution here and select the TigerGraph version 306. And let's choose the Graph Convolutional Networks V3 and next. And you can choose the platform, and let me just use another TGC4M16 and use the Virginia version, and I can choose a disk, let's say 128 gig. I'll keep the partition factor and replication factor as 1.1, and put the information here. And this is the password that you would need to get into the Graph Studio interface of this solution, and provide a subdomain demo. Okay. Next, there's a place that you can look at the summary and see whether you want to do any changes. If not, let's just submit. All right. It usually takes 3 minutes to 5 minutes for it to provision. So I'm not going to wait. So I already provisioned one instance before this, this webinar. So let's just go into the specific starter kit. All right, so I get to this GCN starter kit. And as you can see, I'm at this citation graph subgraph. And let's look at the schema. The schema is relatively simple. There's the paper, edges, citation and word, and then these are the layers in the convolutional network. And then the next step, you usually need to load the data if you have a new instance. I already finished loading this. And let's just go directly to write queries. Yeah, I already did one of the run before. But as you can see, I already installed the queries. So you will need to reinstall the queries if you do it the first time. And we also provide a README here, which is a feature that in many of the starter kits, if there's sequence dependency, in these queries, we'll provide README and tell you which query to run first. In this one, this is the in-database machine learning GCN model. So there is 4 different steps you need to go through. First is initialization. Let's just do that, initialization. Run. Okay, so it finishes. And README 2 is a wait initialization. Let's go here. Okay, it's also finished. And third is training. Let's run the query. And we have some default parameters here. Of course, if you are experimenting with it, you can change these parameters as you see fit. And let's just run the queries. Okay, we have all these output here, and I feel okay for now. And let's just go back to the last step, which is predicting using the model that we just trained. Okay, let's run this query. All right, so this is how a predicted output that you can get from the starter kits. As you can see, there's the citation weight, edge, and also the type of paper. And so yeah, so this is a simple process and an example of using TigerGraph to do in database machine learning, especially using the technique of graph convolutional network. So there are one thing I want to really mention about the graph convolution network and why it's very beneficial to use, a graph database like TigerGraph, is we can, well, first of all, you know, because you can incorporate the graph features of each of the vertex, graph convolutional network can actually achieve higher accuracy with a low label rate. So this is one of the benefits of first leveraging, the graph convolutional network technique to work on some of these data set. And secondly, why TigerGraph, right? So TigerGraph is a distributed database that actually allows these type of in-database machine learning. And for many of the applications, a graph can have hundreds of millions of vertices and billions of edges. So which means a lot of these matrix and features matrix can really consume a lot of memory during model training. So if you are using, TigerGraph, the distributed graph database, where the graph can be distributed among the multi-node cluster, and also maybe partially stored on disk, and also the graph structure user data and social, such as the social graphs and consumption graphs, you can already store in the graph database in the first place, right? And then after that, the in-database model learning can also just help you to, you don't really need to export the graph data from the data management tool again to another machine learning platform, but you can just, work inside TigerGraph, and this definitely help you to iterate in training your different models. Okay, so anyway, this is kind of a really quick overview on this pretty complicated topic. I really encourage you to explore the starter kit yourself, as well as reading some of these this paper that helps you to understand. And I'm happy that on this paper, you still need to do some of this manual step yourself, but with the December update, we already have this starter kit that you can avoid this some of this how-to steps. Okay, let's just go back to the presentation, and now I'm just going to shift back to Reyes to talk about the 3.1 update. All right, thank you.
Thanks, Emma. Let's go back to the second part of our presentation. All right. Okay. Sorry, and gonna switch back to, okay. So I just want to present 3.1 feature overview and introduction as part of this webinar. Just before I go into the details, just talk a little bit about what 3.1 means for us. Version 3.1 is our first feature update in 3.x series. 3.0 was a major release for us. We did, as you have followed, we redid a lot of the platform, and pretty much the product was, had major updates. So 3.1 actually builds on top of that. We've added some new exciting features, and we also added some enhancements to our core capabilities. This is in line to make, to make sure that we are still ready for enterprises and as the only database, a graph database in the market. So with any feature release, we typically have product focus with respect to what are the themes or areas we want to focus on, because these are quarterly releases. So that helps us narrow the focus down. For 3.1, we picked availability, security, and operational excellence as sort of the three pillars. On the availability side, our goal is to enable customers to run business critical workloads. We already have HA, but obviously HA is not sufficient in some cases. So we've addressed some key areas to further enhance and make sure TigerGraph is ready for tier 1 applications. On the security side, we really wanted to enhance to allow enterprises which have really large user base and also may have diverse set of use cases, in which case how to make it easy to run one single database instance, sort of like one unified system with necessary safeguards in place from a data access perspective. And the last thing is operational excellence. When we run a distributed system, there's always that operations overhead. That's always a worry for operations staff, for DBAs. So we've added some features to basically lower the threshold. That way, either you are a new customer who's moving to TigerGraph, or you're an existing customer, that as you get more familiar with the product with 3.x, you're able to operate at a much lower cost. That kind of the three pillars we have for this thing. And if you look at the benefits, as you can see, we didn't go for one particular set of users. We wanted to address needs of all of our core constituencies, starting from the bottom, operations and administration, which is typically the operations staff. Um, Operational excellence pretty much is for that core constituency, like allowing easier access to logs, easier configuration management. All of this is geared towards making the job of the operations staff easier. If you go up the stack, enterprise architects, again, availability, that's a core concern for an enterprise architect. If they're designing an application, they want to be able to rely on database to provide the guarantees in terms of consistency, availability. And those are typically are things that enterprise architects would worry, and we have addressed some of the concerns for them as well. Now, obviously, when we extend the GSQL language, as we have done in 3.1, that allows enterprise architects, it gives them the freedom to build applications with much more ease. And finally, but last but not least, the app users themselves. These are the end users who use our system. For them, we've added, like, obviously the security aspect is critical, and allowing easy data sharing without compromising access controls will allow app users to get access to more data as they build applications across the entire graph. Even if you have a graph that is deployed through multi-graph, this kind of gives you easier access, easier data sharing, and all of that. And then in this release, we're adding SQL-like tabular output, which is again a key win for app users. If you're data engineer or a business intelligence analyst, if you have familiarity with a lot of the downstream application BI tools, this release is really good for you, because here you can get the power of TigerGraph aligned with all of these downstream tools that you're really familiar with, and you can really it opens up possibilities to do a lot more. Um, all right, so let's actually go into the features themselves. I just want to start off with a caveat that, obviously we cannot go down deep dive into any of these features because the content is a lot. So my goal at this point is, as I said here, it's feature introduction, just to give you a glimpse of what all is in 3.1. And some of these features are pretty big, would require a deep dive sessions on each of them. A webinar can be put together. So keep that in mind while I go through fast from feature to feature. First, I want to start with introducing the concept of continuous availability. The reason why I'm mentioning we were using the word continuous is because this is sort of the key differentiation we're adding in 3.1. We've always had high availability built into our product, but that's, as I said, is not sufficient. When you are running a database, you expect availability at multiple levels to work. So with continuous availability, we are actually going beyond the basic requirements of any system that has HA, and this will allow us to allow users to have business continuity. Um, Besides obviously enhancing uptime for multiple services. And the way we're doing it is through three key features. One, we have improved the fault tolerance against failures. Whether it's data operations, metadata operations, configuration management, all of these can withstand failures now at the hardware level. The second thing we're doing is we're providing full native HS support for user-facing applications. I will go into details in the slides next. Basically, what this means is we want to have users to have seamless uptime for all their user-facing applications. For example, GSQL, the Graph Studio, to survive outages at node level. And the last thing is the failover to remote clusters in a disaster. Because this is so far before prior to 3.1, our focus was all about handling errors that happen within a cluster. But if your entire data center or a region were to go down, obviously, that'll none of the HA capabilities would work. So, which is the scenario typically seen with a disaster, and we're addressing that as well with a feature called cross-region replication. So put it all together, we really wanted to highlight that we have crossed a threshold, and from for HA to more another plane, and we started using the term continuous availability as it seems more appropriate given where we are with our product. So I'll start with the first big feature on the availability side, GSQL Server and Graph Studio HA. By design, TigerGraph has HA built in, as I mentioned, for all our internal components. For example, GP, GSC, REST services, they all have primary and backup. And if primary were to go down, the backup would take its place. And so that from a user request perspective, we are able to handle requests seamlessly. However, by design, we had kept the user-facing applications, GSQL and Graph Studio, not have HA. And the reason for that is it would our principle was it would be incumbent on the customer design based on their business requirements if they would require HA or not for each of these components. With 3.1, we're making a change, and in fact, we're introducing HA for both GSQL and Graph Studio by default. If you have a clustered environment, obviously, HA would be set up for you so that there's no single point of failure even for these user-facing applications. From a benefits perspective, obviously, this reduces the operational overhead a lot for the operations personnel, because they do not have to worry about that particular node that could be a single point of failure. And for users, obviously, this means their productivity goes up no matter what happens on the cluster side. If their GSQL client connection fails on one node, within a minute, it'll reconnect to another standby server, and they're back in business. So it's a win-win for both the operations as well as the end users. Um, Take a quick look at the architecture itself. It's a fairly high-level overview. Prior to 3.1, looking at a TigerGraph cluster, you would typically have one GSQL server running on M1 node. The rest of the servers are only for data processing. With 3.1, we're changing the design, and we'll have GSQL servers running across the cluster on each node. And the number of servers is configurable. By default, it's 3. So of the 3, we'll have one as the primary server and the 2 as standby servers. And the interaction from the client side doesn't change. It's the same. They can connect to any of the servers. If it goes to the primary server, obviously the primary server takes the request, performs the tasks. If it goes to a standby server, the request is redirected to the primary, and the primary, of course, does the work. In terms of the responsibilities of each of these servers, the primary continues to process the client communications, query requests coming from those clients, as well as any user management requests. For example, if they do any changes to token management, privileges, all of that is still with the primary server. What does the standby do? Standby is a little different. Standby comes into picture only when the primary fails. Obviously, one of the standby is elected to be promoted to be the primary, and then they take over and do all of the functions of the primary server. In addition to that, obviously, when primary is in a healthy state, the standby servers redirect requests whenever there's a request sent to them. From a user impact perspective, nothing changes. For you, this is all done on our side. So the GSQL client will work as it did before 3.1. So there should be no change in terms of how you have used GSQL client prior to this. All of these changes are transparent, are hidden from you. This is just about adding HA in how we do it. I hope this gives you a quick view of the feature. Now, moving on to the second feature in the availability area is the disaster recovery support. Now, this is a new feature for us, net new, because here now you can actually span the TigerGraph services across data centers, multi data center deployment. You could have two separate clusters in each data center, each region, and then they will be able to seamlessly work together. Uh, as you can see, the functionality wise, this not only enables disaster recovery, but also there are additional business benefits to the customers in terms of enhanced availability, enhanced performance, improved system load balancing, and then also if you configure two clusters in the same region, you could also use it for data residency compliance. I'll go over one by one. In terms of the enhanced availability, obviously, the fact that we can synchronize data across two clusters makes it easy for you to have availability. Say if your entire cluster were to go down, the other cluster is still available for you. And this need not be a disaster event. Even if you were doing a planned downtime, you're doing the whole data center is being upgraded for some hardware upgrades or some other things that are that require significant downtime. This will allow you to you be in business and still your application services will still be running. On the enhanced performance side, this again allows you to spread um, customer application requests more uniformly, because the way we've designed this feature is that the remote cluster is also available for read. It's not a cold cluster. So that allows you to get more out of your investment, and you can distribute your traffic, use application traffic across both of them, and thereby improving your throughput as well as the performance of the queries. And the second one is kind of in the same vein, system load balancing. Like you can decide based on your application load how to divide, like 50-50 or however many clusters you have. That way you kind of set thresholds so that one particular cluster doesn't get a bulk of the traffic and becomes a hotspot. And the last thing on the data residency, I would say, is since cross-region replication allows you to replicate data, some of the compliance requirements that you have with respect to data sovereignty and localization can be addressed by creatively setting up clusters in the same region, multiple clusters. Because the way we have designed cross-region replication is that it doesn't, the different clusters need not be in different regions; they could be in the same region. So let's look at a quick overview of the design and how it looks. Um, with with this feature, disaster recovery support, we plan to provide complete native support for all of the data and the metadata operations. Looking at an example here, we have two clusters in one in data center one and data center two. They're two different geographical regions. You have to consider one as the production cluster. That's the primary where all of the updates and reads and writes would happen. And then it's very key distinction. And the second cluster that's considered the remote cluster can only have reads. And what happens is all of the writes operations that happen on the production cluster in region one will be seamlessly replicated and applied to the remote cluster as well. Now, this data transfer happens asynchronously, so there is a little bit of a gap when the data would be available in the remote cluster. But your remote cluster is, again, as I mentioned before, it's not a archival or a cold cluster only to be used when there's a disaster, but in fact you could use it actively for querying as well. So from usability perspective, you're looking at two clusters, except one is read write, the other one is for read traffic. And the way we are rolling out this feature, as I mentioned, this is a new feature, it's a broad area. We've taken a phased approach in terms of releasing it to the customers. In 3.1, we are addressing the core data operations. By core data operations, I mean anything that changes the data itself. For example, any of the loads, reads, writes, or anything that changes the data in the database is supported. What's not supported in phase one is metadata operations, which is creating schema, changing schema, or user management operations. All those would be handled in phase two, which will be released as part of version 3.2. So we do see with this feature beyond disaster recovery, we have already seen a lot of interest with customers, and some of the customers are trying to deploy it, use this feature for more like a blue-green deployment model as well. So there's a lot of possibilities with this feature. All right, transitioning off to the next area. Security is, like I mentioned, is another key pillar of 3.1 feature set. In 3.1, we're releasing Vertex-Level Access Control, VLAC for short. This feature is designed to work similar to how row-based access control works in the relational databases. This is an important extension to our security functionality. TigerGraph already has multi-graph. We already have role-based access control. Now, with this, we will be able to provide much finer granular data access controls. Basically, the concept is VLAC presents updatable views of the data itself. Like for basically based on predefined types and the using tags, you can define what lengths through which you want to see the data. Basically, tags are individual properties on vertices, which grant privileges to users to see only specifically those properties. um, I'll walk through an example that'll make things a little bit more clear. For users who are operating on those through VLAC, they will be working only with the tag based graph. They don't look at the entire graph, the base graph, which has all of the attributes. So in a way, it silently filters out the data that they're not supposed to see, in similar to how row based access control works. Let's walk through a quick look at a depiction of how VLAC works. Um, as I mentioned, tag-based graph is like a filtered view, right? So in this example, you have on the top, you have the base graph that has lots of vertices and lots of data, but the bottom is where the tag-based graph is. In the tag-based graph, which is the syntax shows create graph tag A as base A, that kind of defines what subset of properties of the vertices in the base graph that user is allowed to see. Only those will be visible. For example, as you can see in the tag based graph at the bottom, it only shows the filtered limited set of information. Um, and this is more like a logical abstraction that we create so that users can only see limited information. Let's do a quick walkthrough example that kind of shows the steps. Again, this is one feature I would say in 3.1 that can take a full hour if you really want to do a demo, and because there's a lot of background material and actually a workshop you could run on this feature. So I'll start with the key steps. Obviously it doesn't cover all of the steps that you have to do, but it'll give you at least a high level idea. So first step is to create a tag. If you see, as I mentioned, these are tag-based graphs. So with a schema change job, you can create a tag and that defines the property on which what are the different ways you can define that property. Once a tag is created, then you want to create a tag-based graph. That is the filtered view of the base graph, which the users can query. And then once you have created the graph, the next job is to add tags to those vertices. And there are three ways to add tags. One is through a manual loading job. We have made changes to the loading job syntax to allow to accomplish that. The second three is we have included a number of functions to manipulate tags, and those could be used in a DML query to do the same. And the third thing is implicitly ingest vertices with tags. So if you already have a graph, a tag-based graph, and if you really want to inherit all of those properties, that's a normal operation. So there's three different ways you can do that. Like in the manual loading job perspective, like I said, we have changed the syntax of loading job to add two keywords, one tags that defines what the tags are, and then there's a second keyword called by, which kind of depicts the behavior. Do you want the new tags to be added to the existing tags on the vertices, or do you want to override it? So it kind of defines the behavior of once you add vertices, what behavior you want to take. And the second thing, as I said, you can also add tags through functions in a DML query. An example is listed here. And the third one is obviously it's an implicit inheritance of the tags. And want to quickly speed up a little bit. And the querying of the tag-based graph is no different. There is no special syntax. You'll continue to use the same querying mechanism that you do with regular graphs, and it should work just fine. So basically, that's from a user experience perspective. There's no difference. You will continue to follow the same querying model that you did previously. And next feature on the security side is the logging. One of the things we have added is some of our customers, especially in the government sector, keep track of all the user requests and for compliance reasons. We've always had fair robust logging in our database on all who accessed what data, what was the request status, and all that. But there were a couple of gaps, and we have addressed all that, and now we are able to provide a lot of the information. For example, all of the user information for requests, like who initiated request, where did the request come from, what does the request look like, what was the status of the request, what are the request parameters like runtime parameters. All those are captured in logs. And if you're a customer and you have a compliance need for audit, that information that with 3.1, you could easily plug that log data into your tool monitoring tool and be able to track basically data access. And then moving on to the third pillar, which is the operational excellence. I basically one of the things we have added is query level monitoring. When you manage a multi-user environment like TigerGraph, you have multiple competing queries running, so you always have issues with one query probably taking disproportionate amount of resources. To address issues like that, we are providing finely grained memory utilization of queries so that the operations staff can take necessary action, either to cancel the query or to make sure that necessary optimizations are made to the query to address any performance issues. I have an example here of the logs of the sample data that shows what sort of information is provided. We provide the amount of query at various stages of the query. Like if a query were to run for a long time, you will see updates on a constant in near real-time basis that track the amount of memory that grows over time. So in a way, you can actually track the history and performance of a query over a period of time. And if a query is regressing in terms of performance, it's easy to capture now because of the level of stats we provide. However, one other thing is the system level stats that we were used to provide with 3.1, they remain the same. There's no change to that. So that you get you already, whatever you got before 3.1 is already there, and this is just an enhancement. Second thing on the operational excellence is the AdminPortal enhancements. AdminPortal is our GUI tool for operations staff to manage TigerGraph cluster. We always add ongoing enhancements to add more functionality. Typically, functionality that's available on the CLI side, we want to bring parity to the GUI side as well. In 3.1, some of the things we've added is one, allow users to view logs, download logs. This makes it easy for admins or other operations staff not to log on to the platform. They can do it through the GUI itself. And besides that, there's also other things like, for example, setup, configuration of security. Now that's feasible through GUI. And other things like cluster configuration management, like setting up REST API services, Nginx configuration, application server setting, all of these which were solely available through CLI now will be available through GUI. One thing before I really want to hit those, whatever I've covered so far is on the three pillars of the product focus we had. But like I said, 3.1 has a lot of other content as well. I just want to touch one other area as a key feature. One thing we've added in 3.1 are two key enhancements on the language side as well. First thing is the Sql-Like tabular output that I mentioned to you before. That will make app users' life very easy, and it makes the application migration to a downstream application as if they are writing from a relational database. I'll have some details about what that looks like. And the second thing is the the more powerful support for language in the distributed mode. So we have a distributed mode and interpreted mode as other ways to query the data. And there's the language support is always, there's always gaps. And we are trying to close that. And in 3.1, we have pretty much completely covered the nearly the full scope of the GSQL language in distributed mode. So if you are if you are an application developer, you don't have to worry about whether a query would work in non-distributed versus distributed. If you go from non-distributed to distributed, you don't have to rewrite the queries. So that's a big win. So quick look at the SQL-like select statement that I mentioned about. This is designed again along how a SQL-like select statement would look like. The output of this statement would be, of course, a tabular output with a number of column expressions. We're also introducing a group by clause as part of that. Now, the functionality wise, the keyword is select is followed by a list of expressions in how when you do a data extract, and each of these expressions could be a column, would be a column to the output table, but from the TigerGraph side, it could be either an attribute or it could be an aggregate accumulator. And once the translation happens, it's to the downstream application. It'll look like we are just outputting a bunch of columns. The syntax is presented here. We have added a lot of details in the documentation. And then in terms of the downstream application that will work with, we are working with certain vendors to provide more detailed integration, and we'll have details later. So at this point, I want to, in the interest of time, I want to transition off to the summary part. Emma, you want to go over
Thank you,
the, yeah.
Reyes. Wow, there was a lot of features, and both Reyes and I trying to just give an overview of what TigerGraph's product and engineering organization has been doing in the past, I would say 3 months, and then it's a lot of content, and definitely expect multiple workshops coming out of these new features, and we will be announcing these workshops and also additional webinars to introduce each different features in the next few months. So I just want to, just quickly summarize again that TigerGraph is a cloud-first organization, and the TigerGraph engine itself was already designed for the cloud environment from the very beginning. It is a distributed graph database, and it can scale out, which fits the new cloud computing paradigm. And of course, in the version 3.1, all of these features are also designed for cloud. For example, the cross-region replication. This is to provide enhanced disaster recovery in TigerGraph Cloud platforms in the future. And the GSQL and App Server HA. And this is also provide a better continuous availability for TigerGraph clusters on tgcloud.io. And then for the AdminPortal features, all these UI-based features for this DBA security and configuration task, it's also helping cloud users to use these DBA type of tasks through easy to use UI interface. And of course, the audit logging and query level monitoring provide better observability for cloud users. And it actually also allows for future optimization on cloud platform to help our users to really writing queries and doing all these auditing better. And then for the last part, of course, like these are just the main points, right? But the last part for the GSQL Vertex-Level Access Control, these enhanced, it really provides the enhanced security access for finer grained data access control on all the cloud environments. So all of these features, in addition to some of the other ones that we didn't have time to mention, everything we're designing for TigerGraph to run smoothly and seamlessly in cloud environments. And just to let you know that the 3.1 will be on TigerGraphCloud.tgcloud.io very soon in the next month or two. So just stay tuned when we have the announcement that 3.1 is available on tgcloud.io. So with that, let's go into questions and answers. Thank you. Okay, I actually will start with one question first because I saw there's one of the attendee asked about Kubernetes and stateful sets and YAML files for the HA setting. So I want to just let everyone know that we're actively working on Kubernetes support, and stay tuned for the publishing of these YAML files in the next few months, as well as webinars. And there will be webinar introducing the K8s support.
Yes.
Any
Do you
other
have
questions? Okay.
I can't see on my screen, Emma. Do you see anything else?
I think, okay. Yeah, so can you explain the tagging in a vertex level access control? Like, how does
y-
that impact performance?
Good question, actually, because I think I should have covered that as well. So tagging does not, you know, like add to the overhead on the query performance side, because that's the beauty of the native implementation. From It's almost like they are doing, like I mentioned, it's an updatable view, right? So it's like they're we don't actually create at runtime a separate copy of the data. So it's the same copy of the data, it's like adding another additional predicate. So the overhead will be minimal to nothing, actually.
Okay, I see another question. It's probably for me. Are there other types of machine learning starter kits on TigerGraph, tgcloud.io? So yes, we actually have a few machine learning starter kits on tgcloud.io. Not just this graph convolutional network one, which is in database machine learning. There are two more. One is another type of in database machine learning for the movie recommendation. So take a look at that starter kits. And of course, TigerGraph, many of our actually users use TigerGraph to do graph feature extraction and then feeding to another machine learning platform. So that there's another starter kit on tgcloud.io that also covers that type of use case. Okay. Next question. What are the advantages of cross-region replication beyond DR? I think you covered, right, Reyes? Yeah.
Yeah, I covered. Yeah, just to re-emphasize, as I mean, that I think the key thing I want folks to take away is this is the cross-region replication feature is not just for DR, like where the remote cluster is only to be used when there is a DR event. From their business and usability perspective, that's an active cluster, except it takes only read traffic. So as I mentioned, it provides you enhanced performance, enhanced availability, and if you are doing maintenance of clusters, planned downtime, you could use that cluster as a way to switch back and forth as a blue-green deployment models, as some of the leading companies do. You could use that for that reason as well. So you get a lot more return for the investment with this feature than with a typical DR deployment.
Okay. So I guess there's one last question. Any new features on ML/AI? Reyes, do you want to take it, or I can?
Yeah, so ML AI is going to be an area of focus for us. In 3.1, looking into the future, actually in the short term, we're working on ML workbench. That'll basically, this is to address the ML ops aspect. How do you create, manage models, do the lifecycle management to make the life of data scientist easy. Because we don't want to coordinate. That's going to be a big area of focus. Stay tuned.
All right. I think we're at the top of hour. Okay. All
All
right.
right. And if
Yeah.
you have any questions, please do feel free to reach out to us.
Yeah.
We love to hear from our users, customers,
Mhm.
and respond in a timely manner. Thank you.
All right. Thank you. Bye.
Bye.